All right, time to get going. A few things to do today. And there's some things that I forgot to put up here. One is, oh, by the way, when Quinn comes in, assuming Quinn comes in, can somebody remind me to give this to her? Um, you're going to have a quiz tomorrow, and the quiz tomorrow is going to be about winds and pressure and stuff like the stuff I went over yesterday. So we'll review for that. It doesn't say that anywhere here, but that is something. So your only homework is really to study for that. Don't forget to study. Some of you have been forgetting to study recently. Um, so the new thing today is not exactly the water cycle. You've probably seen the water cycle before. That should be sort of a review. But it's formation of clouds, how clouds form. We've already talked about it a little bit earlier in the year. So it'll actually be there's nothing new here except we're putting some things together you've already learned. All right, so the warm-up. Oh, and more. I've got a Bill Nye water cycle video. We could watch a little bit of that if we want. We don't really need to, but sometimes it's fun to watch Bill. Oh, the preview of things to come. Hopefully that link works. Do that in a minute. So here's the water cycle. There are 4 parts in it according to this diagram. Some of the diagrams of the water cycle are really complicated. This one just has, good morning, Aiden. Good morning. Evaporation, condensation, precipitation, collection, and then back to evaporation again. And the thing that makes it a cycle is the fact that it just keeps going around and around and around and around. In here, the important parts really are going to be evaporation and condensation. Those are the parts we're going to be talking about a lot. So first question, when is water a liquid? So during this, in which of these stages? I guess we could go through each of them and I could ask you, is it a liquid or is it not a liquid in each of these? So let's do collection first. Collection is when the water that's fallen from the sky collects in lakes and rivers and things. Is water a liquid there? Yeah, definitely a liquid. How about evaporation? When it goes up into the sky before it forms the cloud, is it a liquid there? Well, it depends on what part of evaporation you're talking about. Like this is liquid. When the liquid gets evaporated, it turns into a gas, and then it's not a liquid anymore. So evaporation is really the process of changing from a liquid to a gas. So I don't know. You could kind of say it starts as a liquid and ends as a gas in evaporation. But evaporated water is right here, right above this mountaintop and below the cloud. Can't see evaporated water. When it's a gas, it's invisible. All right, condensation. Let's just say condensation is the forming of these clouds. So the clouds have formed. Are those clouds liquid? Are clouds liquid? So I saw a pretty confident yes here, and then a general no there. Cloud. Way back in class number 15, I think we talked about clouds. I was looking through this last night. Yeah, what are clouds made of? Why don't they fall? We talked about this a long time ago. How fast will a piece of chalk fall? Anybody remember? Like when we see that white, what is that? Anyone? Nobody's, oh, you know what? I haven't even joined the meet. Let's see if there's anybody there waiting on me. No, didn't matter anyways. Nobody was there. So I better present though. All right, so if we can see the clouds, which phase of matter are they not? Solid, liquid, or gas? If we can see it, it's not a gas. So do you think they're solid or do you think they're liquid? Liquid. And if it's really cold, sometimes they could be solid. If those are snow clouds, that's little pieces of ice up there. If those are, hey Quinn, I was just having people tell me when you got in so I could give you this, but I guess I'll hold on to this. Are you going to be here tomorrow, do you think?
I don't know.
Okay. Will you see anybody who's in here that I could
I
give
don't
this
think
to?
so.
What?
I don't think so.
Okay. Well, I'll just hold on to it. If you could think of a way that I can get it to you, let me know.
Okay.
I could drop it off in the office. I could give it to whomever. Okay. So the answer to that is yes. Like the condensation. It's kind of like evaporation. In condensation, something starts as a gas and turns to a liquid. So by the end of condensation, something is a liquid. And clouds form through condensation. Sometimes they freeze right after that. All right, precipitation. Is it a liquid? Can it be a liquid? Yes. Could be a solid. So it could be a liquid or a solid, but it's not a gas. That's when everything falls from the sky. All right, so I guess we've really covered number 2. When is it a gas? That would be at the end of evaporation and at the beginning of condensation. Number 3, what causes each of the events? This is important, especially what causes evaporation and condensation. Does anybody know what makes the water evaporate? If I had some water, usually I've got some water sitting right. If I had a puddle of water on my desk, what would the water need in order to evaporate? Let me switch to. I'm going to go back to the FET simulation that we watched a long time ago. Can't see this too many times. States of matter. That's not what I want. Yes. So when this opens up, I'm going to have a couple of options, and one of them is states, one of them is phase changes. I think either one of these would work for me. But this, I'll make this water. These are water molecules, and they're generally, they didn't do a great job of this, but they should be connected. The white pieces on one should be touching the red on another, because the red is a negatively charged oxygen, and the white is positively charged hydrogen. They're sort of doing that. They're not really forming nice little hexagons. Maybe if I cooled this water down more, I wonder if it would go into a better crystal structure. At any rate, I don't know. That's not great looking. Those aren't great looking water crystals. But if I want to melt this and turn it into a liquid, I can just do this, and I can tell it's a liquid when it starts to kind of spread out and flow over the bottom. It's not doing it. It's almost like there's no gravity here. Maybe I just haven't given it enough time. Anyway, if I want to make this turn into a gas and evaporate, this is sort of boiling and evaporating are kind of similar, but I just give it more energy, and eventually some of these, like that one just evaporated. That one evaporated. So these down here, they're still liquid. They're all bouncing around. They've got sort of about the same amount of energy, but every once in a while, one of them just gets enough energy that it escapes. So the answer to what causes evaporation, if I go back to here, what causes this? It's heating. So the sunshine falls on the ground and on the water, heats up the water, turns it into a gas, and then that also makes it rise because hot stuff rises. All right. So then it condenses back into a liquid. What causes that? If heating causes it to evaporate and turn into a gas, what could I do to turn this back into a liquid? What? Cool it down. So if I cool it down, then that slows the molecules down. They don't bounce around so far or so fast, and they come back together. So this is water looking more like a liquid. And if I keep on cooling water down, then it solidifies. So back to here. The evaporation is caused by heating. Condensation is caused by cooling. This next part, do you remember, does anybody remember why I said, going back to class 15, why clouds don't fall? They're little droplets of water up in the sky, so why don't they fall? If I have a droplet of water and I let it go, it'll fall. But those clouds are made of droplets of water and they don't. I asked a question about, I still got some chalk here. How fast will a piece of chalk fall? And I dropped it. And remember what I did next? No? Okay. Maybe I didn't. I'm pretty sure I did this, but maybe it's just so long ago. I think what I did was I crushed it up into little tiny pieces. I don't even know. Let's see, what would be a good, there. So I'm crushing the chalk up and I'm trying to make chalk dust. And each little tiny piece of chalk dust is basically a little piece of chalk. But if, I don't know, you can't even see it, but I can see it just floating in the air. And the only difference between those little pieces of chalk dust and the big pieces of chalk is, hey Jace, I don't know Jace, what happened to your seat? Just, yeah, pull that other one back that Anna was, just pull it back a little bit and you can sit there. So it's just the size. Once raindrops get to a certain size, they have what's called a high, or a high terminal velocity, so they can fall faster. So when things are really small, they just can't fall very fast, so they just hang up there. So what happens to cause precipitation is the raindrops just have to get bigger. Collection, I'm just going to tell you that. That's just water flowing downhill into lakes and stuff. But the important thing is evaporation is caused by what? Heating or cooling? Heating. And condensation is caused by cooling. And I could demonstrate one really easily. I'll have to leave this. I'll have to take my mask off. But what I'm about to do over here, demonstrate evaporation or condensation? What? Condensation. Here goes. So that was condensation. Now, if you keep watching, you'll see evaporation. These are little tiny droplets of water that came out as a gas, hit the window, cooled off, condensed, and now the air in the room is heating them back up again, and they're evaporating back out into the air. So I'm not going to keep watching my breath evaporate forever. Oh, let's see. Briefly revisit. We already did that. All right. I want to take a just quick trip to the weather forecast. And the question that I had for you is, in general, will the air pressure be higher when the air is colder or warmer? We're about to look at the weather forecast for the week, and you're going to see a graph of temperature and pressure, and they're going to go up and down. And I want to know, when we have cold temperatures, when the air around us is cold, do you expect to see higher pressure or lower pressure? And when it's warmer, do you expect to see higher pressure or lower pressure? It'll take a second for me to get to this. There's something about this link that initially doesn't work, and then I have to put in Essex again, and then it'll work. Probably. Essex. Maybe you have to agree to their cookies. It's kind of slow. It's doing something though. All right, before I actually show you the 10-day forecast, which is where we'll be able to see this, what do you think? High pressure, if it's warmer, will the pressure be higher or lower? This is a tricky one. Pressure will be lower when it's warmer? Anybody disagree? All right, let's see. And then we'll talk about it. I swear I'm making this go as fast as it can. It's just gotta load all the ads so we can look at the ultimate shave comfort. And I may need to customize this. On my computer, it's set up so that I can see temperature and pressure, but I may need to, oh, no, it's all good. So here's today, high of 20, low of 8, supposed to get about an inch of snow. The black down here, this is barometric pressure measured in inches of mercury. So see the black going down, 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 then up a little bit, then back down again, then up a little bit. And it's pretty high here. And then temperature is the red. So there's temperature, there's feels like, and then there's the dew point. So if you look, as the temperature's climbing up here, what's happening to the pressure? Going down. And then the temperature goes back down a little bit, and the pressure goes up. And then the temperature goes back up a little bit, pressure goes down. So, Elijah, why were you were right. What was your reasoning there? Yes, exactly. And I wish I had done this. We had done this a few days ago when we had the really cold air, because the pressure went way up and the temperature went way down. This red line here and the black line almost touched because the red temperature was so low and the black pressure was so high. So the colder air is, the heavier it is, and pressure, atmospheric pressure, is caused by the pressure up above us, or sorry, the weight of the air above us. So if we have heavy cold air above us pressing down on us, we're going to have higher pressure. And that's what you see kind of right in this area over here. The black is high, the red is low. But then as the temperature starts to go up and the air around us is warmer, it's not as heavy, so the pressure starts to drop. And another thing that you see, we're going to talk about this too. Look at the trend in sunniness and cloudiness. What do you notice when the pressure starts to go down? Does the weather get sunnier or cloudier? See right here, Friday, it's sunny. Now watch, I'm following this black pressure. Going down, 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 down. What happens to the weather up there? And then look, the pressure goes back up. What happens to the weather? And then the pressure goes back down. What happens to the weather? And then the pressure goes up. So when pressure increases, we generally get sunnier, clearer weather. And then when pressure decreases, we get cloudy weather. Remember the thing with the cloud in the bottle? When do you see the cloud appear? When you squeeze or when you release? When you squeeze, does that cool off the bottle or heat it up? It heats it up, and it makes the water inside the bottle do what? Condense or evaporate? Evaporate. So when you squeeze, that heats up the bottle. That's high pressure. That clears the skies inside. That's like what's going on right here. Tomorrow, we have high pressure. That's like the sky is being squeezed. The air above us is going to be heavy. The sun's going to come out. And then the pressure starts to drop. That's like the air being, instead of being squeezed, that's the releasing part. Then the clouds start to form. And then we get some snow. And then here it looks like it's starting to get squeezed again. And then we get clear skies again. And then it's released again, and then it's cloudy. So this was, sometimes I go to this and it just doesn't obey the rules at all. And everybody says, oh, this doesn't make any sense. But this is a pretty good trend here. All right. Enough of that. Oh, why am I going to my email? I've lost my way. Let me just go back to my website this way. Okay. So a preview of things to come. I've really been giving you a preview here, but this is where we're going with all this. You're going to be, just like with plate tectonics in the end, we put everything together in this giant diagram. That's kind of what we're going to do with climate and weather patterns. But some of the things to note here, if I zoom in on this, if you read this, this says subtropical high, equatorial low, subpolar low. And then if you look over at the side, these are the kinds of diagrams we've been drawing. This is where air is rising at the equator. And the fact that it's rising tells you that it's what? Heavy or light? What kind of air would rise? Heavy air or light air? Jace, light air. And if it's light air, then the pressure below it's going to be low. That's why this is called the equatorial low. And then at about 30 degrees, this is where air is sinking. This is called the horse latitudes or the subtropical high. It's sinking there because it's heavy. And another thing you see is if you look at the high pressure at the horse latitudes and you look at the low pressure at the equator, what's this puffy white stuff at the equator? Can you guess? What's that supposed to represent? There's some more puffy white stuff at 60 degrees. What are those puffy white things? Maybe if you look at them, clouds. So the equator, there are big rainforests there. There's a lot of clouds. You can see them over here too. And this is just what I was just showing you with our weather pattern. This is low pressure, and low pressure is associated with clouds and precipitation. And this is high pressure, and high pressure is associated with clear skies and deserts. So all the major deserts of the world, like in Mexico, the desert southwest of the US, they're right along here. If we kept going, we would get to the Sahara Desert. And there are actually big forests up here. This is actually a place where there's a lot of precipitation. And then another thing you can see here, this gets a little confusing because we haven't learned about the Coriolis effect, but these red things, those are winds. And see the high and the low, are they going from the high to the low, or are they going from the low to the high? What are they doing? Jace, high to low in every circumstance. So this is the subpolar low, and these winds are going toward it. These winds are going toward it. This is the subtropical high. The winds are going away and away. So we've got, after today, one more new thing to learn, which is the Coriolis effect and sort of the circulation of the atmosphere. And then we're going to put all this together and figure out all the different climates of all the different continents. Okay, back to, I've lost my way again. Here. Bill Nye water cycle. And water cycle. So the first thing we need to do is go over the homework. So you're supposed to do this. If you have it, if you wrote it on a sheet of paper, get that out. And if you didn't write it down and you just did it, that's okay. I'm just going to quiz some of you over this. Ask you these questions. I'll just go around the room and see how people do. It's kind of like what I did yesterday. I'm going to get my pencil out so you can tell me how to draw this. Like I said, feel free to get your sheet out. You can answer right off your sheet. So let's see. Skylar, what causes wind? Oh, it's RJ. What causes wind? Yes. Harriet? Pressure. Megan? Louder. Differences. So it's pressure. I'm not going to write all these down, but I'll write this one down. Pressure differences. Now, number 2 and 3 kind of go together. What determines the direction wind will blow? How will the wind blow in the diagram down here? So Aiden, so looking at this diagram, this person right here, there's going to be a wind blowing across that person. Which way is the wind going to blow? Is it going to blow to our right or to our left across the person? What do you think, Aiden? You are correct. Now, Harriet, why does it blow to the right? High pressure to low. So, Harriet, which way is the wind going to blow across this person? Yes. And then how about right here? Left. All right. So the winds are going to go from high to low. Number 4, what causes atmospheric pressure? So all around us, we've got about, I'm going to go ahead and give you the answer to this. The average air pressure at sea level is about 15 psi. It's 14 pounds per square inch. What's causing that pressure? Cassidy, what causes air pressure? So it's air. Which air in particular is causing pressure on me? Let me put my picture back up here so if somebody's watching the stream, they'll see it. So let's say instead of this being air, this is all rocks around here. I would feel the pressure of those rocks. Why? Because of gravity. And now, where would I feel the pressure of the rocks? If I were on the top of the pile or the bottom of the pile? The bottom. So the air isn't rocks. It's not that heavy, but it's the weight of the air. There's still miles and miles of air. And it's confusing. If we're in a classroom it looks like, well, the ceiling's right there, so there's not much air above me. But the building is not sealed. Every time somebody opens the door, all the pressure from the atmosphere outside rushes in through the door. If we could seal the building and pump out all the air, first of all, it wouldn't be strong enough and it would just collapse. But anyway, we'd die, and I don't know where I'm going with that. But what I mean is, even though the ceiling is above us, we still have miles of air above the building that contributes to the air pressure. So what causes atmospheric pressure? This is super important. Everybody needs to know this. It's the weight of the air above us. All right. So if you know that, then you can answer this next question. Alyssa, your turn. Where is air pressure stronger, at higher altitudes or at lower altitudes? Lower, yes. And Cassidy, why? So if there's somebody here, this person experiences more pressure than somebody who's standing up here. The weight, and who has more air above them? Right. So if this is the top of the atmosphere, this person has this much air on top, this person has that much air on top. So that's why this person feels more pressure. So if you travel rapidly upward, you go from where this person is to where that person is, what's going to happen to your eardrum, Alyssa? Is it going to stretch outward or inward if you go from here to there? What's that? It's going to stretch out. So you tell me why. I'm going to draw the picture. So this is if you go up, here's the pressure in your head. I'm going to draw the pressure in your head in both cases. This is pressure inside your head pushing against your eardrum. When you go up, Alyssa, does the air pressure around you increase or decrease? Increase? Decreases because there's less air above you. So if I'm going to draw the air from the arrow representing the pressure outside, when you go up high where there's less pressure, do I make the arrow longer or shorter? Shorter. So which one's going to win? The one from the inside or the outside? Here's a strong pressure in your head, weaker pressure outside. Which one's going to dominate the other? The pressure from the inside or the outside? Inside. So it's going to stretch your eardrum outward like that. And that's because as you go higher, you have less air above you, so the air pressure is weaker. So this will probably be easy at this point, but that's okay. Laura, what's going to happen to your eardrum if you go from a high place down to a low place? It's going to stretch which way, out or in? No, it's going to stretch in. So in this case, if you go downward, so you start out in position A and you go to position B, do you now have more air above you or less? More. So is the pressure around you going to be weaker or stronger? The pressure comes from all this weight. This is like a pile of people or rocks or whatever you want to call it. The higher up you are, the smaller the pile on top of you. When you go lower, there's more piled on top of you. So the pressure is stronger. So as you go down, this pressure outside your head becomes a lot stronger than the pressure inside your head, so it pushes it in. All right, so number 8, Elijah, what does PSI stand for? Pounds per square inch. Pounds, you know what pounds are per square inch. I weigh somewhere around 190 pounds, I think. So if I were to stand up and put all of my weight on a couple of toes, just so I'm pushing down on an area this big, whatever I'm standing on would be experiencing 190 pounds per square inch of force. And that would probably hurt, if I stood on, I don't know, what's some harmless, not quite harmless animal I could use as an example? If there were a wildebeest lying on its side, and I stood on a little area on it that big, that would kind of hurt the wildebeest. But on the other hand, if I just took my whole body and I lay down on it like this is me, and spread out all my weight over it, then that would be a lot more square inches. So there wouldn't be as many of my 190 pounds on each one. All right, I'm getting distracted. So average pressure at sea level, I already told you. The suction cup. Jace, why does the suction cup stick to the glass? What? Anna, can you explain? So you got the key part is when you first put a suction cup on something, you squeeze it against the glass or the surface, right? And that pushes all the air out. So there's no air under here. So if I want to draw the air pressure pushing against this suction cup, from what direction do I need to make my arrows? If I want to show all the air pressure pushing on that suction cup, from the bottom, because there would be air out here pushing the suction cup that way, but the reason suction cups work is they remove the air on this side, so the pressure just pushes from one side, so it makes it really hard to pull it away from the glass. If you don't squeeze out the air and you just lightly touch it to the glass, then you've got the air pressure pushing in from this side, but there's still air underneath it pushing back the other way, and so it doesn't stick. It's not like it's forced against the glass, but here you can imagine people pushing it away from the glass and people pushing it toward the glass, so it's not stuck. Here, there's just stuff pushing it toward the glass. All right, diagram below. We're back to Skylar. Label the heavy and light air masses. So which ones should I label heavy? We've got some that say warmer and some that say colder. Which ones are the heavy ones? What's that? Don't know? How about this? What kind of air rises? Does cold air rise or does hot air rise? Hot air rises. So if it rises, do you think that means it's heavy or light? What? Light. So which ones should I label light? Warm. So these are the lighter ones. Lighter, heavier, heavier. All right, so below the masses, I'm going to label the areas of high pressure and low pressure. RJ, tell me where to put the H's and the L's.
H and the L's?
Where do all the H's go?
H's go to warm.
So the
No, L's
here are the places that I'm going to put letters. Below, I'm putting it below this air.
Yeah.
Where do the H's go? Below the warm air or below the cold air?
Warm.
No, because the pressure, remember, is caused by the weight of the air above us. So if that air is heavy, then we're going to have higher pressure. So this is high pressure, this is high pressure, this is going to be lower pressure, and this is lower pressure. Megan, so now I want to draw the winds. Which way should I draw the wind here? To the right or the left? To the left? And how about here? To the right? How about here? To the left. Okay, Harriet. Now I want to do the rest of the circulation up here. Wherever there's cold air, should I have that air rising or sinking? Sinking. And warm air, I'm just going to assume is rising. Now I've got some other places where I need to finish the pattern right here. Which way does this air go? Look at what's happening here. To the left. And how about right there? To the right. And right here? To the left? To the right? Is that your final? Think here. To the right, yes. So this should just cycle around. If you go like this and then you hit something going the opposite way, you've done it wrong. And then last, this was, I told you this was optional, but I think this is a good thing to discuss. There are some places that have sometimes they're called onshore breezes and offshore breezes, or ocean breezes and land breezes. And what they're caused by the fact that if you've ever been to the beach, have you ever burned your feet on the sand? So sand changes temperature. It gets really hot during the day. And then at night, it actually cools off really fast. And the water stays pretty cool all day. And at night, it doesn't really cool off much. So sometimes when I grew up in Georgia, the state of Georgia, and we would go swimming in the day and the water would feel really cold. And then we would go swimming at night, and guess what the water felt like then? It would feel warm. And the reason was not that the water was cooling off during the day and then heating up at night. It was that it was that the air was getting really hot during the day, so the water felt relatively cool. And then at night, the air was cooling way down, so then the water felt relatively warm. But the water didn't change temperature much. So that's what's happening here. So can anybody tell me which way does the wind blow during the daytime? Does it blow toward the water, or does it blow toward the land? And at nighttime, it's going to be just the opposite. Can you figure this out? You've kind of got a 50-50 chance of guessing, but if you think about the concepts we've just been talking about, and think about what would cause wind to blow, either this way or this way, you should be able to figure this out. Elijah or Anna, do you have a guess? What? I can't hear you. What? From the sand to the water during the day or during the night? During the day? Let's check it. So during the daytime, the sand is hot, the water's cool, so that would affect the temperature of the air over the sand and the water. So this air is relatively cool, and this air is relatively warm. So what does cool air do, rise or sink? It sinks, and I guess you could say that there's high pressure under this because cool air is going to be heavier. And then the warm air rises, and the pressure underneath that would be like low pressure because warm air is not as heavy. So if you look at the H and L, which way is the wind going to blow? To the water or to the sand? It's going to blow like this. So during the daytime, you actually get an onshore breeze. As the land heats up and the water stays cooler, that's going to make this sink and this rise. But at nighttime, when this is cooler and this is, or actually I'm going to call this, and I'm going to call this warmer. It's not exactly warm, but relatively speaking, this gets colder and this is warmer. So this is going to start to sink, and this is going to rise, and here's where your high pressure will be, and there's where the low pressure is going to be. It's not necessarily high and low, it's just higher pressure and lower pressure. So I've been to the beach. I've tried to pay attention to which way the wind blows. I've never actually noticed this. It must happen in some places. Another thing that supposedly happens is this thing called the down valley and up valley wind. And when the sun rises in the morning, they say that the mountain peaks, because they've got more surface area, they heat up faster. So they're in the morning, they're warm. And the valley below takes a long time to warm up, so it stays cool for a little while. So my question for you is, that's going to make a wind that does what? That goes up the mountains or down the mountains? Think about this. Do this. If you can figure out like what this is going to do to the air pressure right above the ground, and then you draw the winds going in the right direction, you got it. Anybody have a guess at which way the winds blow in the morning? Up to the peaks or down to the valley? What do you think, Elijah? Up to the peaks? Okay, let's check it out. So the peaks are going to warm up, and that warms up the air right around them. And the valley is going to stay cool, and that cools off the air. So this air is light, and it's going to rise, and it's going to create low pressure. And this is going to rise and create low pressure. And this is going to sink. It's heavy, so it creates high pressure. And the wind goes from high pressure to low pressure, like this. And I suppose if I was going to draw the circulation pattern, it would go like that. And then in the evening, just the opposite thing happens. These cool off faster, and the valley cools off slower, so it's warm. So you get warm rising air there and cool sinking air here. And then you have what's called a down valley breeze. Or I think sometimes they call them mountain breeze and valley breeze. Okay, let me go back to my website and see how things are going. 8:41. Instead of doing the notes today, I think we'll just kind of call it good. So people at home, there's really nothing new, except that on Monday, all of you blue people, you're going to have a quiz over these kinds of questions. And it's going to be pretty much the same as this, but if I do a diagram like this, I might not have high, low, high, low. It might be low, high, low. It might be low, high, low, high. So you have to understand the concept here. And down here, if I do a diagram like this, I'm not going to have the same pattern of warm air and cold air. There are going to be some places where there's warm and there's cold, but it's not going to be exactly like that picture. I'm not going to ask you questions like these unless they're bonuses. So if you didn't do this yesterday, let me show you where it is just so you can see. It's in Google Classroom. Oops, forgot to assign this. That should just say meet. So Google Classroom, class number 60, this was yesterday. Here's the link to it. So you can practice this and watch this video over and over if you want to. Or maybe I should write out the answers for people, figure that out. Okay, so Quinn, Soli, I'll see you later. I'm going to sign off here, and we're going to do a few more things with just the gold people. All right, so gold people. You have, some of you didn't do very well on this quiz right here. So the first thing we're going to do is you're going to get a chance to retake this. Remember this quiz last week? So I want to briefly go over this with you before I give you another chance, because I don't know if some of you have been studying this or not. But I think the first part, at least, where you have to list all these things from oldest to youngest, I think you got that. Most of you. Some of you didn't. But the second part, what in the world is that? Zamboniing the hallway? The second part is not hard, but it's just that some of you, I think, didn't practice. I don't know. Maybe you didn't do the homeworks. There were a couple of homeworks practicing the second part. So the first part, remember you find the oldest thing at the bottom, layer B, and then you work your way up. So there's E, and there's D. Which one's older, D or E? E? E, yeah, because D cuts through it. So E is next, and then D. Then the next thing I see F and G. So G is younger, F is older because G cuts through F. And then I get to J. And then after that there's H. And here's the top of C, and here's the top of I. And the one that's oldest of the three is what? H, C, or I? Which one's the oldest? H, C, or I? Alyssa? Which one is old? Of these three letters, letter H, letter C, and letter I, which of these layers is the oldest one? H. Why? Because C and I both cut through H. Now, C and I are next. They're both below A, so A is not next. Which one's older, C or I? Alyssa? C. How do you know? Right. So the earthquake broke C. The earthquake cut through C. So the C had to be there before the earthquake. But the earthquake didn't cut through I, so I had to come after the earthquake. So there's C and then there's I. And somewhere on here it says in your list, make a mark showing when the earthquake appeared. So it's right here. This is the quake. And then the youngest one is A. All right, so I got those out of the way. Now, so I've done this, and I've done this, and I actually can go ahead and do this next, I'll do the next part. And then I'm going to go up and do number 3. So for this section, which one's barely older than E, and which one's barely younger than E? So I just look at E. The older one on the old side is B. The younger is D. So I just do B and D. And then I'm asked the same 2 questions about H. Which one's older and which one's just younger? So there's H. So the older one is J and the younger one's C. And then for F, if I look at F, the one that's older is G and the younger is J. And then for I, the one that's older is C and younger is A. And then for G, the older one's D and the younger one's F. All right, so those should be pretty good on those. And this next part's not too bad either. Number 4 says, in no particular order, the ages of I, C, D, and G are 20 million years, 15 million years, 10 million years, and 5. Write their ages in the table above their letters. So the first thing I'm going to do is just going to circle those. There's I, C, D, and G. So it's those 4. And with those 4, I have to match up 20, 15, 10, and 5. So the oldest one is 20, and D is the oldest one, so that's this one. And the next oldest one's 15, so G is the next oldest, so that's got to be 15. And then the other 2 are 10 and 5. So given those 4 ages, I have to match them up with these. I just look and see this is the youngest, next, and I have to make sure that I get those in the right order. I skipped number 3. Number 3 says in the fossil row, describe any fossils you see in any of the layers. So I see the bug in layer F. I'm going to write bug. And I see the snail in layer B. It doesn't really matter what this thing is. You can call it anything you want. Snail. All right. So I've got all those done. Now I've got to do number 5, which if you do all this, you ought to be able to get this right. How old is layer J in figure 1? Choose the most likely age for layer J. So here it is. Now, how am I going to figure out the age of that? I don't have the age. But I know it's older than C, and I know it's younger than G, so it's got to be something between 10 and 15, right? And the only thing that's between 10 and 15 here is 13. So now the earthquake. How long ago did the earthquake create the fault in figure 1? So I put my little mark right here between C and I. The earthquake came after C and before I. And so it's between 5 and 10. So which one of these is between 5 and 10? 8. Now layer L, this is where the fossils come in. Layer L in figure 2 is this one right here. And I want to know the age of that. But I don't have any information about layer L. But I do know what about layer L? It's got the bug. So it's probably about the same age as whatever else has the bug. And the other thing that has the bug is F. And F is between 10 and 15. So this has got to be something that's between. Did I do that right? L has the bug. F has the bug. Between 10 and 15. You know what? I think I had that wrong on my answer key. Oh, wait a second. Did I get this order right? F is older. No. My order is wrong here. Look at my G. Is G older? Wait, no, G is good, then F. I think I might have had my answer key wrong. I might have graded some of your papers wrong. Look at my answer key for this. Yes. On here they are?
Yeah.
So, yeah, oh, G cuts through F. So, yeah. I don't know why I'm having so much trouble. So I got this wrong. So G is 15. And that changes my answers to these. Let me go back and check some of these. E, B and D, so those are good. J, G and H. Wait, no, H is J and C. That's good. F should be D and G. I wouldn't have done so well on my own quiz here. And then I is C and A. And then G, F and J. All right. Well, you can see that even I screw this up sometimes. So back to this. So I was thinking that seems wrong. I'll give you a little hint that you won't have any of the same answers here. And I had the same answer there, and I thought that's kind of screwy. I don't remember having a same answer. So for layer L, I guess what this goes to show is you need to really be careful. I wasn't even careful enough. Layer L has the bug. The bug is also in layer F. And layer F is between 15 and 20. So that would be 16. And then finally, K has the snail. And B has the snail. And B is older than 20. So it would be 21 as a possibility. So I have, does anybody have questions about any of those parts? Oh, and also I told you that this quiz was going to be over the rock cycle. And I forgot to put anything about the rock cycle on it. So I've added 3 rock cycle questions onto it. And I'll just show you. The other class had to do these. We'll do these together. This will be really easy. People who already took this and got a good grade, you don't have to retake the rock cycle part if you don't want to. So think about this. This type of rock forms anytime another rock is broken into bits and then compressed together again to make a new rock. I'll come back to that. This type of rock can form when another type of rock is heated, but not melted or squeezed by pressure. And then the third one, this type of rock forms anytime another rock is completely melted and then allowed to cool and harden. So we've got the first one that's broken into bits and then compressed back together. We've got the second one that's either heated or squeezed, but it's not melted. And then we've got the third one that is melted and then allowed to cool. So this first one, the one that's broken into bits and compressed together, is that igneous, metamorphic, or sedimentary? Alyssa? C. So now the second one, the one that's just squeezed or heated or both but not melted, what's that? Anyone? Megan? Metamorphic. And the third one, the one that's completely melted and then allowed to cool and harden, that's an igneous rock. So, like I said, if you got 100% on this last time, and you don't want to bother with it again, you don't have to take it. But I think most people will probably want to take it again anyway. I think, yeah. There's only one person that doesn't need to take this again. All right, here you go. Do your best. Go slow, go carefully, double check so you don't do what I did. Yeah. So you may want to do the 3 on the back first. That way you don't forget they're there. And we just talked about them, so they'll be fresh in your mind. In fact, I'll hand out the rest of these upside down so people can see those. They're not in the same order. I took the same exact questions from the rock cycle and I switched them around. Cool. So don't put the answers in the same order that I just did. Need a pencil? You'll have to sharpen it. I'm doing mine at the same time, and I'm going to go back over it and carefully check my order this time. Yeah. Thank you. What's that? Just, well, I'll just take off one for this, but fix it and I just want to see what your answers are there. You can use this or not. Thanks. Mm-hmm. think what I'm going to do on the grades on this, some of them are a lot better. Some of them still have a ways to go. I'm only going to put these in Power School if you have a passing grade. If you don't, I'm going to have you take it again sometime. I'll try to sign you up for AST, and we can work on that. So, a few of you got the order of everything right when you wrote it on your list, but in number 10, you didn't write the letters down right, and I didn't take points off if you ordered it right. Which was all right. I don't know what happened in that section. I didn't take points off for it. And anybody can take this again if you want to. Just have to go with the time to do it. Most of you, I think, probably all set. And if you had the order wrong on your, that's what. If you had the order wrong, I wrote the correct order down.